scientific domain, the industry, the government domain, and the farmer community to discuss about the role of geospatial data in agriculture. And we started off this CAPIGI in 2005. Then it was mainly concerned with the use of GIS and satellite data by government institutions. But of course, in the past years, the precision agriculture domain entered as well, and they use exactly the same tools as governments, but then not for compliance checking or proving, but also for improving the farming practices. And I think that the third element here is that governments, and especially the European Commission and the policymakers, now see technology, and also satellite technology in particular, as an opportunity for farmers to make the transition to more sustainable farming. And that's, I think, why there's a huge interest from everybody in satellite data, in what it is, what it can do, what it can bring, and how to apply it for your daily business, whether you're in science, in industry, in farming, or in the government. So today we have a program that is focusing on sharing the latest trends and technologies on space data. I'm very happy that we have Benjamin Lieberknecht from European Space Imaging, who will explain about what kind of satellite data they are delivering. Then we have Eric Silman from Planet, who is also showing us the latest developments at their company. And then we have Elise van Tilburg from Wageningen University, who will introduce to us the topic of, or the main topic of the discussion for today, which is remote sensing and privacy. Because privacy issue, I think, is a big thing for everybody nowadays. In this age of information and intelligence, everybody is concerned about the data, about the sovereignty they have over the data, and about what everybody else is knowing about them. And there's of course a good reason for that. We've had several displays of misuse of data with Facebook, for instance, or with other things in the past. And in order to prevent that, I think the farmers' unions, under the lead of Kopa Kojeka, developed this code of conduct, where they basically say that everybody who is using farmer data should have the farmer's consent, and to use it and reuse it, and should be clear about what you do with the data. But what if the data doesn't come from the farmer? What if the data comes from space? So I think that is I think, creating a situation that is not really covered by the GDPR or other privacy issues, and that's definitely something we need to discuss today. So we will first listen to all the great opportunities and all the benefits and risks that satellite data bring, and then we move into the discussion about the privacy issue. So without further ado, I would like to give the floor to Benjamin Lieberknecht from European Space Imaging, and he will reveal to us the latest developments that they are bringing to us. Benjamin, please go ahead.
Okay, I will share my screen. Okay, is it visible now?
Yes.
Perfect. Okay, thank you for having me. I'm Benjamin, and I work for European Space Imaging since 2015. So nearly 6 years now. I'm sales manager. And for those who are not familiar with our company, I quickly introduce ourselves, and then I will go through what we can do and what we will be able to do and what this means for agriculture. So our brief history, it all began in 2002. We were founded in Munich, Germany. And yeah, since then we had a lot of milestones and steps. The first one was in 2004, where we made some, where we founded a cooperation with the EU Commission and other governmental bodies, and it's still ongoing and will also continue in the future. In 2010, we formed the alliance partnership with Digital Globe, which is now known as MAXA, and Space Imaging Middle East. And in 2014, I think some of you might be familiar with this date where the regulations of 30 centimeter imagery were loosened. And we then launched WorldView 3, and this is until now, it will change this year, but it is until now the only 30 centimeter satellite commercially available. In 2017, we had a big investment here, and we now have the ground station at the DLR, which is able to direct uplink and direct downlink the data to the MAXA satellites, which I will introduce later. This year, or no, it's already 2021. So last year, we formed a strategic partnership with Ecopia AI and Satellogic. I will talk about this briefly in some of my slides later. So when talking about the MAXA WorldView constellation, I think some of you might know it's the largest historical archive, and it dates back to 2000, where we had the satellite Iconos. It had a resolution of 80 centimeter, and it had already an accuracy of 3 meters. And the highest spatial resolution is now available with WorldView 3 in 31 centimeter and for archive WorldView 4. And we also have this the broadest spectral diversity with up to 16 bands. The 16 bands are, well, the visible bands from coastal to red, and then it goes to the near infrared red edge, and we also have the sphere bands, which are basically used for material detection, heat detection, and cloud penetration. When talking about spectral bands and spatial resolution, I think it's hard to imagine these without any examples. So I just put this slide here to show you the spatial evolution, not the resolution, the evolution for at least our company. In 1999, as I said, Iconos was launched, and the first images were available in 2000 with 80 centimeter. On the left-hand side, you can there see an airplane. Well, it looks a bit like the old video games. You can hardly see the edges of it, and no features on the wings or the plane itself. And when we move further to the right, in 2001, 60 centimeter with QuickBird was launched. In 2007, WorldView 1. It was a panchromatic satellite. And then it started to grow with 40 centimeter and 30 centimeter. On the 30 centimeter example, if you look closely, it's hard to see, but you can read Iberia. So one of these letters must be 30 centimeter wide and I think 1 meter high. So this is captured with WorldView 3 at the airport of Madrid, and you can actually read what's written on the airplane. But what brings like 30 centimeter resolution if you do not have access to your area of interest? So it's also important to not have only spatial resolution, also temporal resolution is very important. So I prepared this just to show you what we can already do now with all our satellites. This shows the ground tracks of the satellites with their range of view in 45 degrees off nadir angle. And with this, we have 2.8 accesses a day over any area in the world. This is the example of Europe because we have direct access there. So for example, when you go to the Netherlands, we can capture the Netherlands 2.8 times a day, your AOI, not the whole Netherlands. This takes about 1 year to cover the whole Netherlands, but your AOI will be covered 2.8 times a day. Important to notice is that we do not task every time, we task on demand and only AOI based. So we do not cover like Sentinel, the whole Earth at once. So we only do it on demand AOI based. In 2021, now we will launch more satellites, 2 satellites, 30 centimeter, which will have a sun synchronous orbit like the others have. And in the next years, 2022 and further on, we launch 4 more satellites to increase our capacity to 10 satellites in total from the MAXA constellation. This will bring 4.5 accesses a day. Some are mid-inclined. That means they only reach up to 40 degrees north or south. So this will be highly frequented, and the northern parts also will have 4.5 accesses a day in future. So overall, we will then have 7.3 accesses a day. So this is just from 2 to 3 accesses in 2000, we will have now then up to 8 accesses in 2021. This year, I already mentioned, we formed a partnership with Satellogic. They have the Aleph-1 constellation, which is still growing, and they are able to capture in future 4 million square kilometers per day in sub-meter resolution. Sub-meter means they have 70 to 99 centimeters. And they currently have 21 satellites, but the constellation will grow up to 300 satellites. But this doesn't mean they will stop there, but this is the goal in future. And this will end up in then 5-minute revisit times for the AOI. So this is their milestones. Now they have 16 satellites, 70 centimeter to 99 centimeter, with 25-meter hyperspectral and also 80-meter thermal infrared on board. They will grow to 100 satellites in the coming years, and TBD 300 satellites with 5-minute revisit times. So I think you're all familiar with the Sentinel constellation operated by ESA. The data is free of charge, available via their platform. I did my master thesis a couple of years ago with Landsat, which had 30 meter. It was already a huge step to get this data for free. And as a student, I was happy to get it for free. So what I'm going to say now, I don't want to say anything bad about Sentinel, the 10-meter resolution. Both the 30 centimeter, the very high resolution, and the high resolution, like 10 meter, have their fields, and I'm very happy that 10 meter exists for free. But I just want to point out the differences of this. So on the left-hand side, you see a field with 10-meter resolution. You can see it's a field or it's something green, but you can't see really the inside of this field, so no patterns at all. If you move to 1-meter resolution or just below, like 99 centimeter, you can see already patterns and see that there must be a field like grapes or something. And if you prove this with 30 centimeter resolution, you can identify single leaves, single plants of vines there. So for agriculture, this means any satellite image is a huge tool and has huge impact on it. So you don't need to go into the field. But if you want to take a closer look at your specific field, for example, 1 or 2 hectares, you need very high resolution to identify individual crops or the health or the damage of these individual plants. So just some solution, I will just briefly mention this, and you can use them for land use and land cover. I've mentioned our archive goes back to 2000, so you can also do change detection in different fields. The food security is also a huge field for satellite images. The forest management, also with sub-meter resolution, you can already identify single trees, or also with 30 centimeter, it's very crucial for the leaf area index, the LAI. So this is very helpful, a very helpful tool, HR and VHR satellites. The biomass can be estimated with all these indices. For example, the NDVI gives you the status of a plant, and the vegetation health can be captured. The red edge is very important for this. And that being said, we had some nice projects with the bark beetle, which kills a lot of trees in Europe. And it's with that satellite, it's possible to identify single affected trees which are affected with the bark beetle. You can also check the livestock welfare. We had a project in South Africa where they tried to find elephants in the Kruger National Park. It was successful, they found some. You can irrigate smarter because you can see the health of individual plants and also the water which is given to them by different indices. Now, when I talked about all this, what you can do, I will show you how this will actually look like. Here you see a 10-meter resolution image with near-infrared 1, red and green. You can identify 2 hectares, that's no problem by measuring this in your GIS system. But if you want to take a closer look at your field, what's happening inside, you can already use 5 meter, which gives you slightly a chance to see, is there something going on? And yes, in this case, there's something going on. There are plants which are not healthy or no plants at all. If you then take 30 centimeter imageries, you can see, yes, indeed, there is something going on. And not only this spot, also other spots are affected. For example, we have hailstorm damage in the northern part of the small 2-hectare field. And we have a production loss due to too much water or anything else in the southern part of this image. But can you really identify there what crops are there if it's not your field and you want to know what's planted? Yes, you can, but not using the near-infrared 1, red or green. You have to change this to another band combination, and then you can already visually interpret the different plants there. So these crops are not the same. To give you something actually happened, and not only images I created to show you some damage, we had a cooperation with TotalView. We still have the cooperation with TotalView, but they did a project with the Technical University of Athens, and they tried to optimize wine from space. So this sounds like a nice idea. Optimizing wine is always good. And they were also at our conference in Munich, and they brought some samples, and actually it was optimized, so I can say that. But how did they do it? So basically, they took some Worldview 2 images with 40 and 50 centimeters and 8 bands, and they calculated 30 indices. Just to give you some examples, the NDVI, the MDWI, the LAI. I think some of you might know all these indices by heart. And they captured a satellite image. So we captured the satellite image and they had the ground truth data. So the in situ data was captured on the exact same time when we captured the satellite image. And what we found out that after atmospheric compensation and optical interpretation, they had a very high correlation with the 8-band data and their ground truth. So actually, the data was the same. So they continued and produced LAI maps, so the leaf area index and the EMAT, which is the mature index of the individual crops. And they found out that it's crucial to have these because they could see actually the whole field in a map, how ripe the grapes were. On the right-hand side, if you see my mouse, you can see that the state of the vines was not the same throughout the field. So then they were able to manage the crop harvesting and selected different areas, different time steps to harvest the wines. So they were able to have the best result for their wine. And this can be also reflected to other crops, like, for example, whatever you like. In Germany, you have here's a beer area, and then in north of Munich, we drink it. In north of Munich, they grow it, and the heap. Yeah. So, and it can be reflected to any crop. And for the later discussion, maybe you can also give some examples where you have in situ data, ground truth, and your field size. And maybe you are already working with drones or something for smaller fields, but satellite imagery, no matter which resolution, can be 10 meter, can be 1 meter, can be 30 centimeter, is a crucial tool for very big fields. And it always saves you a lot of time for your crop management. And I'm happy to discuss with you later all these, also your ideas, how to improve this and your solutions. This is it from my side. If you have any questions later after this webinar, you can also reach me via email or ask later. I'm happy to answer all the questions later.
Thank you very much, Benjamin. I think very great insight in the capabilities and what can be achieved with the satellite data, and some nice examples also for agriculture. I just realized that I forgot to mention the housekeeping rules in the beginning of the webinar, so I will do that now. First of all, this session will be recorded. So be aware in the audience, if you are given the floor with the microphone or the video, that you are also on recording. The presentations and the recordings will be shared afterwards, so you can always reread and re-listen to what has been said. And we of course appreciate discussion and questions. Therefore, we will use the Q&A button. You will find that on the bottom of your screen, Q&A. There you can leave your questions, and we will pick them up. We have a team of moderators ready to find your question and to ask them to the right panelist. We have room for some specific questions right after the presentations, but of course we also have 45 minutes of discussion afterwards. So sometimes we will take up a question to the discussion. I think that is it for now for the housekeeping rules. If I look at the Q&A